Good day to you all. My name is Shivagangatharani, Assistant Professor from IT Department, Kamaraj College of Engineering and Technology. In this video, I am going to present the topic Chinese Remainder Theorem. Let's move to the topic. Chinese Remainder Theorem is a fundamental concept in cryptography, especially in RSA. In RSA, the decryption exponents is a very large number. So we use a Chinese Remainder Theorem during the decryption process to split the number into two small congruences. That helps to reduce the computational time in RSA. First, we understand the basic concept of the Chinese Remainder Theorem. So, Chinese Remainder Theorem is a method to find a number which gives a specific reminders when divided by a different devices. So, I give you a small example for your better understanding. You will understand where to apply the theorem in a real life problems. So, here just assume we having our box of apples and we don't know the exact count of the apples. So there is a two conditions. You are going to divide the apples into three groups. So 2 apples are left over. While you are dividing the apples into 5 groups, 3 apples are left over. Can you find how many apples are present in the box? Here the count of the apple is same, but we are changing the number of groups. When we change the number of groups, the leftover apples counts also changed. So in this kind of puzzles, we can use the Chinese Remainder Theorem to solve the problems. Chinese Remainder Theorem helps to solve the set of different concurrence equations with one variable with different module, which all are relatively prime, which means GCD of M1, M2 up to Mn is equal to 1. Here A1, A2 up to An, these all are the reminders when we divide the x by M1, M2 up to Mn respectively. So it gives a unique solution to find the value of x. To find the value of x, we need a capital M1 and capital M1 inverse and capital M values also. So let's we move to the steps. What are the steps we are going to follow to find the x values? So this first step, we need to find a capital M, which is the multiple of M1, M2 up to Mn. The next we are going to find a capital M1 value. So capital M1 is equal to capital M divided by small m1, capital M2 is equal to capital M divided by small m2 up to we need to find capital N value. Then next step we are going to find the modulo inverse of M value. So for capital M1, M2 up to capital N, we are going to find a modulo inverse like capital M1 inverse, M2 inverse and Mn inverse. Next step, we are going to apply the values into the formula and we are going to find the x value. Here we know A1, A2, A3 up to An values, M1, M2 up to Mn values and M1 inverse, M2 inverse, Mn inverse values also. Let's see a simple example sum for Chinese Remainder Theorem. So x is congruent to 2 mod 3, x is congruent to 2 mod 5, x is congruent to 1 mod 11. From this problem, we are going to take the given values. This is A1, A2, A3 and M1, M2, M3. Totally we have here 3 different congruence equations. So we got the A1, A2, A3 values, M1, M2, M3 values. Now we are going to find the x value, means we need a capital M1, M1 inverse and capital M2, M2 inverse, capital M3, M3 inverse and capital M values also. So now we are going to find the capital M value first. From that we are going to find a M1 and M1 inverse values. So capital M is equal to small m1 into small m2 small m3, which is 3 into 5 into 11. So the capital M value is 165. Now we are going to find the capital M1 value. So capital M1 is equal to capital M divided by small m1, which is 165 divided by 3 is equal to 55. Like that we are going to find the M2, M3 values also. Here the M2 value is 33 and M3 value is 15. Now we got a capital M value and M1, M2, M3 value. Now we need a modulo inverse of M1, M2, M3. Now we are going to find the modular inverse of capital M1, capital M2, capital M3. For that we have a formula. So capital M1 into capital M1 inverse. This is the modular inverse of capital M1 is concurrent to 1 mod M1, which means when we multiply the modular inverse of a number with the number, it gives 1 as a remainder under modulo M1. We know the M1 value is a 55. Now I am going to set a value of capital M1 inverse from 1 to 1, 2, 3 until we reach the condition is true. So now I am going to put the value capital M1 inverse is equal to 1. So 55 into 1 is equal to 55. I am going to divide the 55 by 3. So 16 3s are 54, remaining 1. So the condition is true. So the M1 inverse value is 1. Next we are going to find the M2 inverse value. M2 value is 33. Now I am going to put a M2 inverse value is 1. So 33 into 1 is equal to 33. When we divided this by 5, we will get a remainder value is 3, which is not true according to these conditions. So I am going to change the M2 inverse value from 1 to 2. Now 33 into 2, which is 66. Now I am going to divide it by 5. So 13 5s are 65. So now we get a remainder is a 1. So the condition becomes true. So the M2 inverse value is 2. Again I am going to find the M3 inverse value. Now I am going to set a M3 inverse value is 1 initially. So M3 inverse is equal to 1. So M3 value is 15. 15 into 1 is equal to 15 and divided by 11. So we will get a remainder as a 4. Here the condition is false. Then I can change the value from 1 to 2. So 15 2s are 30 divided by 11. Now I get the remainder value is 8. So here also the condition is false. Then now I change the value from 2 to 3. So 15 into 3 is equal to 45 divided by 11. So when we divide the 45 by 11, we will get the remainder as 1. So the condition gets satisfied. Then the M3 inverse value is 3. Now we find the modulo inverse of capital M1 and capital M2, capital M3. Now we are going to apply all the M1, capital M1, M2, M3 and the capital M1 inverse, M2 inverse, M3 inverse value into the formula A1, A2, A3. These are the remainder values which we can get from the sum. Now we find the M1 and M1 inverse, M2, M2 inverse and M3, M3 inverse and M values also. Now we are going to apply the value into the formula. So A1 is 2, M1 is 55, M1 inverse is y. Like that A2 is 2, M2 value is 33 into M2 inverse value is 2 plus A3 value is 1, M3 value is 15, M3 inverse is 3. Mod M value is 165. Simplify the add all the values, you will get a 287. Then 287 mod so 165. When you divide 287 by 165, you will get the remainder as a 122. So now the x value is 122. Now we got the x value. We can cross check the x value is correct or not by using the given sum. 122 is congruent to 2 mod 3. We will check it. 43s are 120, which means the remainder is 2. Yes, this equation is correct. Now 122 congruent to 2 mod 5. So 24 5s are 120. Then remaining we have a 2. So this equation is also correct. Now 122 congruent to 1 mod 11. So 11 into 11 121. So remaining 1. So this equation is also correct. So our Chinese remainder theorem the correct answer of the x values. So hope this will helps you to understand the Chinese remainder theorem. Thank you.